And we will stick to the topic of chemicals, yet getting a bit more technical. Professor Frank Schael from the university team will now present highlights from the sub-project on chemicals and processes innovations.
Okay, dear audience, hello everybody. It's my pleasure to guide through a brief report on the chemicals and process innovation sub-project. My name is Frank Schael. As Desiree mentioned, I'm teaching chemical engineering at Hochschule Darmstadt. We will have a tandem presentation with Dr. Alex Föller from the TGWA, who co-chaired this sub-project. I also like to mention Patrick Ojan, who performs the desk and lab research. This slide shows the agenda of this presentation. We will start with a discussion of the objectives which were defined in the scenario process and the somehow modified approach after a conference and 2 workshops. Then the results of 3 studies performed in the framework of the project will be briefly presented. Finally, Dr. Föller will subsume our results in current innovation trends of laser chemicals and processes. The objectives were defined and steadily redefined together with the experts in the field. As an outcome of the scenario process, the first objective was to pinpoint the role of chemicals and processes within the laser supply chain. This objective included the definitions of assessment criteria, the actual impacts of chemicals, but also regulations, aspects, and tools to manage the criteria and requirements. Another objective was to develop strategies how laser chemicals can be produced and used in a more sustainable way. The approach encompassed all 3 pillars of sustainability, which are social equity, economic viability, and environmental protection. Finally, the project should help to identify technical and organizational potentials for process innovations. Additional keywords here are inspection of waste streams and improvement of collaboration between actors along the supply chain. However, the international workshops led to some refinements. It turned out that while we can identify a number of important contributions to sustainability of the laser supply chain, we cannot possibly address all of them directly. So the 2 main feedback directions could be distilled from the comments of the participants. The first one we summarized in the question, how can future innovations in laser production contribute to make the supply chain more sustainable? Clearly, technological progress was expected in the workshops to be of major impact. The second question developed because there was seemingly no consent on the criteria which would help us to rate the sustainability of an entire production process. Since these central questions could not be answered directly in workshops, we decided to perform own studies. The intention was to generate results that could facilitate or initiate further discussions with and among the experts from the field. Of course, there are many technological aspects around laser fabrication. We selected an aspect dealing with manufacturing of chemicals and demonstrated continuous flow synthesis of potential laser chemicals on the basis of renewable resources. Furthermore, we started to develop a simple assessment tool for sustainability assessment. Our first study sorry, Desiree, am I sharing the correct screen? Do you see a PowerPoint presentation screen?
Yes, it's all fine.
Yes, it's
okay.
fine.
Okay, sorry, I'm a bit disturbed because I have a message shown here I cannot interpret. Okay, so I just continue here at this point. Our first study aimed at demonstration of continuous flow manufacturing of chemical, which is of course a major trend in current process technology. The expected benefits are smaller space, energy, waste footprint, and improved safety and enabling of small-scale, decentralized chemical production. Scalability, which describes the adaptability to different production amounts, is one important requirement. I cannot go into technical details here, but we found the scalability of the selected continuous flow reactor concept could be shown in terms of flow distribution, in the reactor for various flow rates and reactor volumes, and in terms of mixing performance. that allows conduction of fast reactions in a safe and stable operation. Well, chemistries on the basis of renewable resources play a major role in recent chemical developments. So in our second study, we investigated the synthesis of 5-chloro-methylfurfural CMF and 5-hydroxy-methylfurfural HMF, which was first investigated in detail by Marc Mascal and co-workers. The target compounds are accessible from carbohydrate containing biomass, received a lot of considerable attention in the literature, and of particular relevance as potential new platform molecules. Our approach here was to perform the synthesis in continuous flow operation as reactive extraction, and for preparation of pure products, and to perform kinetic investigations which are necessary for technical applications. The general reaction path is shown in the slide. HMF and CMF are formed in acidic aqueous solutions of sugars under elevated temperatures. As byproducts, humic substances and often linoleic acids are observed. HMF is not stable under acidic conditions, so that immediate extraction into an organic solvent is advantageous. Obviously, the process is driven by reaction rates and mass transport. It's a relatively complex kinetic scheme with a number of open questions. A number of chemical compounds are known, which can be derived from HMF and CMF and makes them promising as potential platform molecules. In particular, the University of Pisa showed that a similar aqueous reaction mixture could be successfully applied as leather chemical. At this point, we already meet 3 green engineering principles that are renewable starting materials. We start with a relatively complex molecule and have a design for separation. For the results, I cannot go too deep into details here, but we optimize the process in terms of yields and green engineering principles by variation of organic solvents, temperature, starting concentrations, and reactor designs. Furthermore, time evolution of products was studied, and kinetic modeling could be performed, which can support the transfer of our findings into technology. The continuous flow process turned out to be advantageous over the batch process, though some issues are still open as more detailed scale-up investigations, heat and mass integration. However, we hope that the results facilitate developments of leather chemicals on the basis of renewable resources. The investigations are currently continued, partly together with interested companies. Our third study developed from the fact that during our workshops, a considerable number of criteria were named for assessment of sustainability of the leather fabrication. The sheer amount of criteria and the complex task to weigh one criterion over the other made a systematic approach and some desk research necessary. So we started to design a simple tool which eventually should allow a leather company such as a tannery to identify improvement potential and virtual testing of raw materials and process parameters. The tool should, however, cover economic, environmental, health and safety, process and social impacts. This slide gives a brief overview, a brief description, of the general concept of the tool. The number of selectable elements are specified, which allows to define the boundaries of the assessment. Single processing steps or an entire chain of processing steps can be selected. Also, more general elements concerning the facility and social aspects are included. Of course, further elements can be added. For each process, a number of assessment categories were defined, such as economic, process performance, input material, EHS, corporate risk. Each of these categories are described by a number of proposed indicators, which were selected from a collection of some 400 indicators we compiled from literature. Currently, we can start with evaluation at the gate of the chemical supplier, if respected data are available. However, we are well aware about the limited availability of standardized data such as product carbon footprint values for chemicals and the discussions on standards such as ISO 140 57 or TSF. We currently test various approaches. We choose an implementation in Microsoft Excel because we wanted the procedure to be as transparent and as easy to operate as possible. However, after the completion of the data input and processing, a direct comparison of different process variants can be displayed. For the display, the results, the data are normalized, allocated to selectable reference units such as square meter or kilograms, and finally converted in relative index values where applicable. Of course, the quantitative figures are also available. The user can then decide on the weighting of the various categories. Please note only exemplary data are shown here on the slide. The tool is not completely ready yet. It is work in progress. It is currently in a testing phase with companies to evaluate the practicability and for further improvement. Let me summarize the first part of the presentation. The sub-project performed 3 detailed studies on the basis of workshop feedbacks. The aim was mainly to facilitate discussions and collaboration among the supply chain. We demonstrated basic technical feasibility for selected continuous flow aspects of chemical manufacturing and developed some proposals for sustainability assessment. Up to now, 2 publications were generated in leading chemical engineering journals. Of course, our research will be continued, and we are still open for collaborations. At this point, it is perhaps interesting to elucidate also more generally the important laser fabrication development trends that were discernible during the past few years. It's my pleasure now to hand over to Dr. Alex Föller, who will elucidate this aspect a bit further. Thank you so far for your attention.
Thank you very much, Frank Schael. I'm the General Secretary of Tegeva, which is covering 100 companies producing chemicals, a dozen of them producing leather chemicals, and among them Smith & Sohn, which is represented by Arnaud. You saw him in the interview. I just want to add some observations that we can make, and that somehow contributes to what Frank Schael has mentioned. And I would like to conclude with a few takeaway messages. At the last EULTCS conference, EULTS stands for International Union of Leather Technicians and Chemical Suppliers. You can see that some or many sessions covered issues that were also part of our process here, in particular when it comes to focus on environmental aspects or new methods or new developments for the leather tanning industry. And you can not only see that in events or congresses, you can also see that in realities, because many companies have already started or are already in the middle of processes of becoming more sustainable. So which is mentioned on the next page, which is also the last one of this presentation. You can see here that many activities take place in the industry. They have to do with process optimization in tanneries by using a larger variety of tanning types or by increasing the machine effectivity. It has to do with optimization of the tanning process itself by minimization or replacement or substitution of certain chemicals of concern. Recycling is an increasing question now, or to become metal-free, to use more renewable plant-based agents, to improve the environment footprint, and what is also very important, to implement a chemical management that allows a tannery to check what are the chemicals I'm using from which producers. Are there some products that I need to replace, or are there innovations that are going on that I can benefit from? And last not least, the leather finishing as well is enjoying some innovations that would make it more sustainable in the end. So you may say some of the processes are probably single measures of companies that are probably triggered by the value chain or have to do with greenwashing or whatever. Nevertheless, I think the key is to make sustainable or sustainability an intrinsic motivation of a company, whether it's a chemical supplier or tannery, and to make it an intrinsic motivation or an intrinsic element of company decisions. I think that two conditions must be fulfilled. There is one condition that is associated with regulating or regulators. Regulations need to provide sufficient time and flexibility for companies to invent more sustainable products and to implement more sustainable processes. And secondly, what is also important in a similar extent is the markets. The markets need to reward the efforts of the leather value chain to become more sustainable. So that is addressed to the retail section or to the brands. It's not possible to sell the same product, which is now more sustainable, at the same price as it has been before. So therefore, there needs to be a kind of reward. I know that is very tricky in those times where we have all to fight with inflation and so forth. And we know that the retail sector in particular is trying to keep the prices in order to protect the consumers. But at the end, to become more sustainable also has to do with more costs. And this needs to be rewarded by the markets. So these are the takeaway messages that I would like to provide to you. And with that, we think we can conclude this part of our presentation. Thank you so much.